Let's have a look at question 2 in this video. So we have a function of x, y, and z, which is xy squared plus 3zx plus 2x squared yz plus 1, and we have to compute the Hessian matrix. And we can see that the Hessian matrix is the second degree partial derivatives. So with respect to x, and then derivative with respect to x again, with respect to x, and then with respect to y, and so on. So let's start it. To get to the second order derivatives, we must do the first order derivatives. So let's do it one by one. First order derivative with respect to x. The function derivative with respect to x, it means that only x is our variable of interest, everything else is a constant. So for instance, x times y squared derivative with respect to x, well, we keep the constant, which is y squared, plus 3zx. What is the constant here? Everything besides x, so that's just 3z. And then from here we have 2yz, which is a constant, so 2yz times the derivative of x squared, which is 2x. One derivative with respect to x is just 0. So as a result we have y squared plus 3z plus 4xyz. Okay. Now we also have to do the second partial derivative, so with respect to x and with respect to x again. So let's differentiate this thing with respect to x one more time. Y squared derivative with respect to x is just 0 because there's no x in there. The same goes for 3z derivative with respect to x is 0, and then 4xyz derivative with respect to x, we just keep the constants, which are 4, y, and z. So it's plus 4yz, and that's just 4, y, and z. What else? The derivative with respect to x and with respect to y. Okay, with respect to y squared derivative with respect to y is just 2y plus 3z derivative with respect to y is just 0, and 4xyz derivative with respect to y is just 4xz, which is the constant. So as a result it's 2y plus 4xz. And the last one would be the derivative with respect to x and one more derivative with respect to z. So y squared derivative with respect to z is 0, 3z derivative with respect to z is 3, and 4xyz derivative with respect to z, we keep just the constants, which is 4xy. Okay, that was just for the first partial derivative. We do now for the second partial derivative. And by the way, one more thing that's going to be handy for our Hessian matrix is to write that the second derivative of x and y, that's the same as the second derivative of y and x, because we'll have to fill in these values in the matrix later. And the partial derivatives with respect to x with respect to z is the same as partial derivatives with respect to z and then with respect to x. Okay, so now let's solve the derivative with respect to y. So yeah, let me zoom out better so we can see the function. Yes, make some space. Yeah, probably gonna do it right here. So f derivative with respect to y, xy squared derivative with respect to y. X is a constant, y squared derivative is just 2y, and then plus 3zx derivative with respect to y, that's just 0, 2x squared times y times z derivative with respect to y, we keep the constants only, 2x squared times z, 2x squared times z, plus 1 derivative with respect to y is 0. So as a result we have 2xy plus 2x squared times z. And that was just the first derivative with respect to y. Now, based on this, we can find out the derivative with respect to y and then with respect to x. And of course, we are going to get to the same result as here, but let's just train the question anyway, train the skill. So this thing, derivative with respect to x now. 2xy derivative with respect to x, that's just the constant, 2y, plus 2x squared derivative, 2x squared times z derivative with respect to x, keep the constant, and then differentiate x squared, which is 2x. X squared derivative is 2x. So as a result we have 2y plus 4xz. And notice it's the same result here and here, as we predicted. Now, second derivative with respect to y again. That's 2x from here. 2xy derivative with respect to y is 2x. Plus, what is 2x squared times z derivative with respect to y? Well, there's no y in there, so that's just... Oh wait, 2xy plus 2x squared. Yeah, the second term, 2x squared times z derivative with respect to y is just 0. So as a result, we have only 2x. And the last one is f second derivative with respect to y with respect to z. So we have, where is it? Here, 2xy derivative with respect to z. That's just 0. And then 2x squared times z derivative with respect to z. That's just the constant, which is 2x squared. So as a result, we have 2x squared. Okay, we did that with y, and last step is to do it with z. So what is the derivative of the function with respect to z? Let's see. X times y squared derivative with respect to z. That's just 0, no z in there. 3zx derivative with respect to z. That's just the constant of 3x plus 2x squared times y times z. Derivative with respect to z is going to be just the constant, which is 2x squared times y. One derivative with respect to z is just 0. So as a result, we have 3x plus 2x squared y. Okay, now let's do derivative of z and then with respect to x. Notice we should expect to get the same result as here, 3 plus 4xy. Let's prove it. The derivative of this function with respect to x now, because that's with respect to z, and we do it again with respect to x. So that's 3x derivative with respect to x. It's 3 plus 2xy derivative with respect to x. That's 2y times x squared derivative is 2x. So that's 3 plus 4xy. Okay, we got that, and it's the same result as here, 3 plus 4xy. So that's good. Z and then y. Well, that's 3x with respect to y, which is 0, plus 2x squared times y with respect to y. Derivative is 2x squared. So that's just 2x squared. And then the second derivative with respect to z and then with respect to z again. 3x derivative with respect to z is 0. And 2x squared times y derivative with respect to z, that's 0 again. So the result is 0. Now, we got everything. So let's put them on the matrix. Let's put them on the matrix. Let me change colors. Something that we didn't use. Yeah, this will be good. It would be good to see the matrix as well. Let me see if I zoom out. Is it visible? Yeah, it's more or less visible. No, not really. So if I zoom out, it's not really visible. Let's just finish off the question by filling in all the second partial derivatives. This step doesn't really matter anyway, just for the aesthetics to have the question finished off. It was 4yz and then 2y plus 4xz. Wait a second. Yes, 2y plus 4xz. I'm just a bit confused if I was looking at the right thing. And then 3 plus 4xy. And below it we have 2y plus 4xz. 2x and 2x squared, and here we had 3 plus 4xz, 2x squared, and 0. That's it. Well, all we just did is we took the results from these partial derivatives and filled in the Hessian matrix in this order: xx, xy, xz, and so on. Anyway, this video is getting too long. We are done.